So moving on to TDD for the model and stubbing out the internet, which we had a preview last time we said we were going to do this. So now we're on to this model method that we've been stubbing out, find in TMDB. So what should it do? Well, we have this introduction to the Ruby TMDB gem, which wraps the API for TMDB. Now, if we had no gem, what the model method would do is probably just submit a RESTful URI directly to TMDB and do something with the results. We do have a gem, so in this case, we just say, well, the movie method should call that gem and make sure that it passes the right arguments to it. And what if the TMDB Ruby gem signals that something went wrong? Maybe the API key that you passed is an invalid key that doesn't correspond to anybody, or you failed to provide one. And this is the first example I think we've seen of explicit versus implicit requirements. So the explicit requirement on this model method is, well, it's got to call TMDB, right? Can't get around that. But the implicit requirement is, wait a minute, when you call TMDB, the docs for TMDB say that you have to pass a valid API key. And if you look at the screencast that's mentioned in the book, it turns out that there's two different ways that could go wrong. One way is if you don't give a key at all, like you leave it blank. And a different way is if you give a key that is not blank, but it's not valid. Right? So there's actually two different implicit requirements that come out of the explicit requirement. The implicit requirements aren't provided by the customer, but they're a direct consequence of doing the thing that is sort of specified by the customer. So we can use two more keywords, context and describe, to sort of group our RSpec tests into cases that cover these two different contingencies. And again, we're not going to do a live demo, but I'll step through the different variations of what test conditions you might want to cover. And I actually made some notes to make sure I don't forget anything important. So there's a couple of, like 3 new things, I guess, in this example that we're going to look at, none of which are particularly rocket science, but they're useful to know. So before, we just had describe to collect a group of tests that are about the same behavior or related behaviors. There's further ways that we can subdivide it using context. So remember we said we're going to describe searching TMDB, but there's a context where we have a valid key, and there's a context where we have an invalid key. And the invalid key context has these two different cases, one of them where the key is not given, and one of them where the key is given, but it's a bad key. Now, why is there context as well as describe? It's for the same reason that Cucumber has given, when, then, and, but they're all synonyms. Context and describe are synonyms. The only reason to use one over the other is whichever one makes the test more readable. So this says, I'm describing tests related to this single collection of behaviors, but the same behavior can occur in two different contexts. It's purely for human convenience to have the two synonyms. Let's see, what was the other stubbing? Here we go. So let's take a look for a moment at the strategy that we're using to test these two different cases of having an invalid key because it's blank versus invalid key because it just doesn't correspond to a key that anybody has. So looking at the blank one, what are we doing for the blank case? We're stubbing the API key method in the movie class, and if you look in the book, you'll see that we develop a simple method that just returns the API key so that you can pass it down to TMDB. We're going to stub the method that usually returns that key and force it to return a blank key instead. Okay, well, you can see why that's a reasonable thing to do if the goal is to test what happens when the key is blank. But looking down here, what happens if we want to test that the key is bad? So it's not blank, but it isn't anybody's actual key. Wait a minute, here we're not stubbing movie, we're stubbing the gem, TMDB movie, and we're going to stub its find method, which is the thing that calls the real TMDB site, and we're going to cause it to raise something. So whereas before we said we're going to stub and return a particular value, here's a case where we're going to stub a method and make it raise an exception. So what's going on here? Why are these two stubs stubbing at different places? The reason for this is when we discussed, in the book when we discussed the behavior of TMDB and the Ruby gem, and there's actually a screencast that shows this in action, is that in fact the two failure modes are very different. Right? So we're using this underlying library, TMDB movie, but it does two completely different things for these two failure modes. If you give it a blank key, TMDB movie knows immediately that the blank key cannot possibly be valid. So it doesn't even try to call TMDB, it just immediately raises an error. So, and in fact, in the screencast, we watched it do that. And what we're doing here is we're exactly mimicking, right? We're creating effectively a stub that mimics the real behavior we saw so that we can test in realistic conditions. In contrast, if you pass the TMDB Ruby library an invalid key, well, there's no way the library can tell if the key is invalid, right? It has to actually call TMDB, and then TMDB will say, whoa, whoa, this key is not blank, but I don't recognize it, right? So that's why there's two different failure modes. The easy failure mode is, we know TMDB, the Ruby TMDB gem is going to barf on this one, so that's fine. We just use this raise error to essentially simulate that barfage, which is a real word. On the contrary, in this case, we know that TMDB movie is going to try to call TMDB. We need to prevent it from actually doing that, right? We don't want it to be the case that every time we run our tests, it will really and truly call TMDB with a known bad key. So we'll stub out the place where it tries to make that call, and we will raise the same exception that we watched it raise when we did this manually, right? So it's a very similar concept. There's a piece of code that we want to break a dependency on. We observe how that piece of code behaves, and then we use seams to simulate that behavior in a controlled manner in our test cases. One other thing to notice about this, which I think is pretty interesting, is let's just pick one of these at random because we can illustrate it with either one. Sure, here we go. So TMDB movie stub, find, and raise a runtime error. Okay, so like I said, instead of saying we're going to stub the method and force it to return something, we're going to stub the method and cause it to throw an exception. The question is, how do you test that that's really what's happening? And that's where this lambda comes in, right? Basically, what's happening here is we're going to make a little procedure that calls find in TMDB, and we're going to wrap that procedure in a lambda expression saying this procedure, when called, should raise an error. Right? And this is a subtle thing, but it's important to realize what would happen if we took out the lambda. If we took out this part, right, and we just tried to call movie find in TMDB, what's going to happen? Well, we stubbed find in TMDB. Find in TMDB is going to try to call TMDB movie. We stubbed TMDB movie and are going to force it to raise an exception. So this highlighted statement is actually going to raise an exception. That's bad, right? If a test really raises an exception, the game is over. The test has failed. Tests should not raise exceptions. However, we want to check, because in this case, the correct behavior is for an exception to be raised. We need to raise it in a controlled environment. And that's what this lambda construct allows us to do. This is just a regular part of Ruby, and it executes this procedure in its own closure and should inspect the output. Right? So in fact, if this expression tried to throw an exception, the exception would be captured as part of the lambda closure, and now should can take a look at it and say, ah, yes, it actually tried to raise this particular exception. Right? So that's what's going on with lambda there. Other than the use of lambda, this actually is just using constructs that you've already seen before. So let's kind of relate this back to our big picture of testing. We have implicit requirements that are derived from the explicit ones. In this case, it was by reading the documentation of the Ruby TMDB gem, by actually watching it interact. When we manually use it to interact with TMDB, we see what happens. And then we use seams to break those dependencies and simulate the behaviors in a controlled manner. And in this case, we had to do it in two different approaches, right? In one case, because we previously observed how TMDB works, we know that with a blank key, we can just immediately, we can catch that error, make sure that we convert it to the right exception type. But in the other case, we needed to prevent the TMDB gem from even trying to call TMDB. We knew that it would try, and we knew that it would raise an error when it tried. That's the thing that we wanted to actually do in a controlled manner. And we saw that you can use context and describe, which are actually synonyms, to group similar tests. And if you read a little bit in the book, it talks about using before, so that if you have a group of tests that are actually related, you can have a common set of behaviors that are executed before all of those tests, and that helps you dry them out somewhat. So this kind of raises a more general question, which is pretty important in a service-oriented architecture point of view, which is, given that the point of stubbing is to control behaviors and break a dependency from your tests, where is the right place to do it? So one example that we just saw is for a blank key, we stubbed right at the level of movie. Right? So from the point of view of the class under test, everything below this point, below this dotted line, was being stubbed away. Right? We got rid of all of that stuff, and we faked its behavior in a controlled manner. On the other hand, we also saw that for one of these cases, that wasn't enough. Right? If we pass an invalid key to Ruby TMDB, there's actually no way for it to know in advance that the key is invalid. It's actually going to try to make the call to the TMDB website to figure that out, and that's the part that we want to prevent. Right? So we can't test that case by stubbing at a higher level, but we can test it by preventing the call from happening at all, right? We can stub its find method. And how do we do that? Well, we look at the TMDB documentation, and it says the find method will call TMDB and do some stuff. OK, well, that's what we want to stub out. No problem. Ruby lets you create the stub anywhere you darn well please. What if the TMDB API was actually less well documented, and we didn't even know, well, OK, there's 28 different methods in there. Which is the one that's actually going to try to call the TMDB website? And how would we stub it if we don't know which method it is? OK, no problem. Fake web. Right? We can stub the entire HTTP client library in Ruby, and there's actually a gem called fake web that does this. It doesn't work exactly this way, but conceptually this is how it works. You basically say, hey, if anybody tries to fetch from this URI, here's how you should react. Or if somebody tries to fetch from a URI matching this wildcard pattern, here's how you should react. And although it's not implemented in this exact way, you've already seen the concepts that underlie its operation. It uses stub, it uses with to be selective about different arguments that you pass could cause different behaviors, and it uses and return to force the return value to something you like. And hopefully later we'll have an assignment on doing Facebook Connect, and we'll basically be testing it like this. What if even that's not good enough? What if you've got a crazy library that doesn't use the standard HTTP support in Ruby, but kind of talks straight to the OS? Well, some services are nice enough that if you're a developer, they give you access to this secondary site that is sort of a copy of the main site, but it only parses requests that are contrived in a certain way. So they're basically, it's like providing a server-side stub. They basically say, here's a test server, here's a table of 25 different values that you can pass to the test server and how the test server will respond. And the idea is that they will let you simulate in a controlled manner whether your app would respond correctly when the real server misbehaves. So for example, if you do any PayPal development, PayPal does this, right? They have a sandbox which has the exact same API as the real PayPal, but it only reacts to a certain subset of requests, and they have a documentation table saying, here's how you use it for testing. So the idea is when you've done everything you can up at this level, the next step is you try to do stuff down at this level talking to the real server, but it's not really the real server, it's the real fake server. Or maybe it's the fake real server. And when we talk about deployment and operations later in the course, we'll see many, many more examples of things like this. So kind of what's the moral of the story here? For unit testing, you're trying to stub nearby because your goal is maximum isolation, right? If we're testing the movie class, then if the movie class does something that goes through this stack, the closer to movie we can stub it, the better, because we're trying to isolate it from its collaborators. And we also want to keep it fast and independent of all these other pieces. On the other hand, if you're doing integration testing, for example, you're running a user story in Cucumber that tests this behavior, you want to stub as far away as you can without breaking independence, because the goal is, for integration tests, you're testing the interfaces. So for Cucumber, probably stubbing somewhere in here would be the polite thing to do. Now, you could say, well, wait a minute, an integration test, you might as well just stub all the way to the fake server, right? If they have a development server, why not use that? And yeah, you can do that, but if you're running thousands of integration tests a day, it's like not nice to hammer their development server. So the idea is you do as much testing as you can up here, and when you're sort of ready to go live, the last set of sanity checks is you run a set of integration tests down here. And we'll use Sauce Labs to do that later in the semester if we can. So the moral of the story for stubbing the internet is, first of all, there's almost always more than one way to do it. And the right place to do it depends on what's the focus of the test. Are you worried about whether the model is working right? So actually everything below the model is kind of irrelevant. You want to make sure that the model can deal with an external error. If so, stub the thing the model depends on and force that error to occur. You can create your own test stubs, like we did for the TMDB site. You could actually manually exercise the site, read the API documentation, see what the interesting behaviors are, and then use the different kinds of seams provided in RSpec to reproduce those behaviors in a sort of controlled environment. And by the way, as an aside, this is how the autograder is tested. Right? The way the autograder works is, for complicated reasons, you can't run RSpec from inside an RSpec test, as I learned. But you can run it from Cucumber. So there's actually Cucumber scenarios that say, if the student submits this code, this is what the output of the autograder should be. And we actually stub out all of RSpec to simulate how your homework gets graded. Isn't that cool? I think it's cool. OK, let's kind of augment our testing technique slide, and then I think we'll be done for the day. So some new stuff that we've seen. One of the things in the previous example that we glossed over a little bit is other things that you can pass to with. we've seen should receive with a particular argument, but suppose the argument is a hash, and all you care about is that the hash includes a particular key value pair. You could say that, hash including. We saw that in addition to stub and return, you can say something like stub and raise if you want to test that a method is raising a particular exception when you call it under some conditions. We saw that you can use describe and context to group similar tests together, and that whenever you have a describe or a context, you can associate a before block that applies to everything within that context, and that helps you dry out some of your preconditions. And thankfully, in this last segment, we didn't introduce any new Rails-specific things, so your brain gets to rest on that.